Schougaard, and my day job is being a professor at San Diego Mesa College. We do what I call emotional intelligent computer science. So we have a team process where we do problem solving, creative problem solving. We just happen to be using computers for that. So, and I want to say, hey students, and even on a bad day, I have a fantastic job. So I also want to practice a little gratitude here to Dr. Steele and Sussman for creating Scheme, for Professors Abelson and Sussman for the structure and interpretation, for the Fallaisen, Findler, Flat, and Krishnamurti for the book we're all using. Yeah. For the creators, contributors, maintainers of Racket, and for the organizers of this conference, without whom we wouldn't be here, literally. I'm also somewhat still in awe that I get to talk at a conference where Abelson and Sussman were talking, so there's that. All right, so I'm going to be talking, there's going to be a lot of opinions. These are strong opinions, but loosely held. The opinions you're about to hear are my own, not the opinions of my employer, organizers of the conference, University of Washington. And so please take it in the context that's intended, like the beginning of a conversation that if we're successful, we'll both learn and we can do even greater things. Nobody's as smart as everybody. All right. So, needs no citation. All right, so there's an old joke in the Lisp community, or outside the Lisp community, that Lisp stands for lots of irritating, silly parentheses. So the question is, do we have a problem? And at least one person doesn't think so. This person will henceforth be known as our intrepid defender of our beloved language. All right. Why do we care? So one answer is that software is made by people for people. And software developers are a kind of people too. Right. In fact, some of my best friends are people. Bjarne Stoustrup has said that design and programming are human activities. And if you get that, and we're lost. What are we even doing here? And Abelson has said that programs must be written for people to read and only incidentally for machines to execute. That one really stuck with me the first time I read that. Let's look at the grade. Oh, sorry. Yes. So let's look at the grade of what we have here. So we have one delineator. Okay, there's space. I'll give you that. But essentially, we have parentheses, and we use it for everything. So there's definitions, function literals, data type definitions, execution, application, whatever it is. And I know, like, they're all lists. My point is, as a syntactic construct, they're delineators. That's how we think about them. They corner off things so we can focus on them. What do the other people do? Well, they have many delineators. And I'm just counting up here. We have curly brace, parentheses, square bracket, comma, semicolon. Like, we got at least 5 of them here. And some of them even have multiple semantics on them. So, for instance, the square brackets, right, are used in 2 different meanings here. Right? We don't have that problem because we only have one, so easy. There is a point here about, is it important to have different kind of delineators sort of saying, we're doing different things here? And there's probably a valid argument out there about that. On the other hand, do I care? Really? Some people might. But there's another side of that. Do we have too many parentheses? Is the other side of that question. But before we move on, I was looking for an objective measure to sort of say we're better than everybody else. And here's what I came up with. So this is a slide by Martin Udersky. And I want to say I have the utmost respect for Dr. Udersky and the great work that he has done taking functional programming into the context of object-oriented programming. He has on several occasions shown this slide, and I shamelessly stole it from his video here. So the languages are Python, Haskell, Scala, Kotlin, Swift, Java, C++, and C#. The question is, where do we fit? And everybody's going, yeah. But, okay, so is it here? I didn't look. Is there a project for some undergraduate on this, finding out where we fit into this? Yeah. Except for the syntax, macro stuff, we are here, right? There's no doubt. I don't know what happens after that. But he makes a good point here. So Dr. Udersky is very happy, thrilled, in fact, that Scala is smaller than Java. Remembering Scala is on the JVM platform. And I might argue that, that Scala is a better Java than Java. And he can actually back that up. The worst thing you can get into here is what C# did. Every new feature, it seems, has a new syntax. And there's one problem with that, not only is the language huge, but you can't get rid of it. Once you get it into the language, it's impossible to get it out. Right? There's always going to be something in there. So you have to be really careful about adding these things. There are several examples in there in C# about they put something in, great idea for the time, solve the problem, and 10 years later, it's like, why are we even doing this? It used to be, and I've noticed this, and I think Rich Hinckley has a similar point, that it used to be that if you want to evolve a language, you add more syntax. Sorry. And that was prevalent before, let's say 2000, and after that, it became prevalent that you add a new library. But like, we can do both because of the platform that we're on. So my argument here is, he makes one more point, which is that Python is smaller than the rest of them because they don't do types. There's no type, well, you can do type animations and annotations, but they're not checked. So you're not really adding much then, that's why it's so small. But, to get back to the structure and interpretation, like it takes 5 minutes to learn. And with my students, yeah, we time it. And so 5 minutes to learn, lifetime to master. We can add features to Racket without growing the syntax per se. We can add all the features we want because we're homo-iconic. Let me give you another example. This is a big picture example. Who's heard of Geeks? Yeah, so Geeks is a transactional declarative package manager. Originally, it was built on Nix, and they're both out there. As far as I know, they're doing really well. Why would you pick one over the other? Well, because Geeks is based on a nice regular language like Lisp. Actually, it's Scheme, and Nix is not. And the people in Nix, deepest respect for the groundbreaking work they originally did, they are now stuck with having to maintain this language and growing it into solving the problems they have. Whereas had they gone with an established language with lots of libraries, their life could have been easier. Another example where we really shine are these things. So I read somewhere that a regular expression is a sequence of characters that specifies a match pattern in text, sometimes referred to as a rational expression. Yeah, who's never heard that before? Yeah, me neither. I looked it up, it's true. There is a reference, and sure enough, they call it a rational expression. I don't know why. But I brought one so that we can all see what they look like. Who would call that rational? By the way, who can recognize what that is? Ah, man. Yeah, you're too good. Right? And how do I know, or how did you know it's a total giveaway right here in the center? Yep.
It's really long and painful.
Oh, good one. Oh. All right, so that's another interesting thing. You called it an @. What's it really called?
I don't think it has an official.
Yes, it does. It's called. No. It's called master space.
What?
Yes, and you have to do it with a British accent. Okay, but other languages, other natural languages call them different things. I believe in certain parts of Southern Europe, it's called a snail.
Oh, I like that.
And then there is another place where they call it a trunk, as in an elephant's trunk. Anyway, different languages have taken different tacks on this. So in JavaScript, we see this thing. So JavaScript decided that they needed another way of delineating things, just to make sure that we have enough delineators here. And it probably implies that there's a data type underneath that's different from other data types. And that has some implications that behind the scenes you can do a lot of cool stuff, like compile these things. Whereas in Java, they took the stance that we're going to do strings. So if we want to be efficient, we have to compile our regular expressions. I could guess here that they initially bet that the JIT would take care of that little problem. And then they found out that you can do much better if you know it's a regular expression. I don't know that that's a true statement, but that would be my guess. All right, so what do we have? We have Scramble. So how many people are familiar with Scramble here? Not a lot, yeah. It's a gem, an absolute gem. So here's what we do. Right, we can define a class of characters that we want to recognize, and we can name them. In fact, here's another one. Not only that, but we can compose them like this. We can have the union of both letters and digits. And so that's one way of composing. So now here we're composing character classes. We can also do this, say it's a letter or a digit. It's another way of composing. By the way, those two work out to the exact same regular expression. If we want to throw in some symbols there, eventually we have this, and then we can take it into an email address by saying we need some of these first and then some of these. I want to say the first time I saw it, I was like, this is brilliant. Best thing since sliced bread. Like, this is the best implementation of regular expressions I've ever seen in any language, bar none. And it still has two flaws. One is that why is RE capitalized when we don't do it anywhere else? And why are we using plus and asterisk here? Because I know my students say, are you adding something? The reason why we're probably having those is because when they transcribe whatever algebra they were working on, I forget the person's name who were working on this, this came out of a session I had once with Peter Nauer of EBNF fame. It's like, how did you end up with those exact characters and doing it that way? He said, oh, he was transcribing what they had written on paper in hand on a typewriter. Right, so they were limited in the characters they could use. but we don't have to be that way. So maybe we could, and there is a repeat function in there that you could call and say, I want so many of these. I'm hoping this works. This is brilliant. I absolutely thoroughly enjoy using it every time I can. Still room for improvements. Another place we shine, you want a thread? No problem, just say thread. Got a thread, give it a thunk, all good. You want to wait for it to complete, you just say wait, like essentially the Unix semantics of fork and join. If you want something that's in a loop, like a server or something, then, and you want to close the server down, you can just kill it. Super simple. What's a thunk, you might ask? So a thunk is just a lambda that takes no parameters. All right, sure. Speaking of lambdas. So let's see. We use lambda this way. Oh, sorry, I have to. So we use lambda this way, meaning we put the lambda sign or word in front of whatever parameters we need. And Jack says, like, what?
I would never.
Let's look around and see what other languages did. So JavaScript, they said, hey, it's a function that takes a parameter and returns some stuff. Right? Super simple. And if you look at the last piece, just look at how much that looks like Lisp. So so I don't know if, I mean, this was one of the things that I believe, my opinion, that JavaScript got right. And I mean, we got to celebrate that because it wasn't that much. All right, so we also have a little bit of irony. Do you see it? It's the only place where we use regular mathematical function notation with the function name first. Huh? So my question is, can we start using function instead? It's a lot easier explaining that to people. Matthew, please. 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 All right. Let's change tracks here. Look at object-oriented programming. So why is that so popular? And the answer is because it fits our natural language. Nouns are classes, verbs are methods, yeah? Life is good. It's easy to interpret. It's easy to understand. Let me just make sure we understand each other here. So let's say person has a run method and a person is a person. Be really careful here. What this is saying is the class of objects which we describe, so a class just means the set of objects that fits in a certain classification, has all of them in object-oriented programming, has a run method. And if a person belongs to that set, then we say a person is a person. Okay? So different programming languages implement this differently. We have dot notation, we have square brackets, we have arrows. We send them a message, and I'll get back to that in a bit. But it's it definitely, the concepts are the same, even if the syntaxes are different. Okay, so let's look at class names. We have this. The rest of the world uses this, and you'll notice I did it on the previous slide, and nobody got up and left. All right? Even in type Racket, the types are capitalized, and I know types and classes are not the same thing. If we look a little wider, there's a little known language called German, where all nouns are capitalized. So Fernsehen and Fernsehprogramm are all capitalized for that reason. Even live stream, and I don't even know how that's pronounced in German. But, right, so you get the idea, right? This is a well-established standard. So can we have that too, please? Pretty please, Matthew. Okay, moving right along. Here's something I really enjoy about being in Ruby on Rails. this makes my life so much easier. I need to know everything that happened between 5 days ago and now. I can do that so easily. What, sorry?
To each their own.
But wait, there's more, right? So what would we do? We would do something like ago days 5, and I know there are languages out there, natural spoken languages that read the other direction, so it would be 5 days ago, which would make sense, but it's not what we do, it's not our convention. And the other example is just like, how do you actually build out these expressions? And the problem is you build them out, from the data to the left, from like in this direction. And it's annoying. So we have key, which is absolutely beautiful, and does all of this so well. One problem, Jack doesn't know how to pronounce that.
That's true.
Yeah. Tilde, bigger than? Really? We can do better, and there are reasons why, but let's just go with this one. It's just an idea. So with do data, so with this data, do these things. Right? And you can already tell with do should be do with. So we're already kind of the language isn't quite working for us there. Compare it to check expect. It's the same thing. Which one comes first? But all right, let's change tracks once more. HTML, we have the top one, the X expressions, and this is what you might see in an XML page. HTML, sorry. One thing here, was HTML made for humans to read or for machines to consume? I actually don't know the answer, and I'm wondering. It's fine. It's a part of the SGML, the standard generalized markup language, so they probably had their reasons. So what do we have? We have this. Right. Okay, so let's just look at this for a second. So we have a single quote, and then we have commas, and then we have a comma at sign. So I call it the fallen quote. It's a quote, but it fell down. It's the unquote. Right? And not only does this just look ugly to me, but it confuses people. It's like, but the comma is just a separator between things. I'll get back to that in a second. Right? So I went and looked at the documentation, and I quote unquote, one of the things to notice here is the unquote splicing of the body arguments. This indicates that the body is a list of X expressions. And he goes, and if they had accidentally used only unquote, then there would be an error in converting the return value to an HTTP response. Okay. Chunking up a bit, the issue here is that we're trying to shoehorn something into something it's not. Right? We are trying to do something by using the easy, but it's not the simple. And this, in fact, is so horrible that I will not give that to my students, so we do this, because I don't want to spend time trying to explain quote, unquote, comma, at, etc. So we stay in the programming language, and then we just add in the stuff that we need. Yeah. So what do other people do? And I took this example from the Play framework. The Play framework is a web application framework following the MVC, Model View Controller pattern. It's available both in Scala and in Java. And the question is, what's on that first line up there? And the answer is, it's a parameter. So what are they doing here? The answer is, this is a view, and even the view is a function. Right? So they said, hey, we want people to write in HTML for whatever reason, And they said, well, we can turn this into a function. So this is compiled into a function that's used on the fly. Their performance is really good. This is not some string expansion replacement algorithm. No, this gets compiled. The @ sign is a coincidence, has nothing to do with anything. But we're in a language where we have higher order functions, so we should be able to do this too. And so, #lang HTML, please. That is a nice little undergraduate project that you can become world famous in the Racket community doing. Right. So can we please have this? I don't care how you do it, the only guidance I can probably give you is that HTML should be a function that returns an X expression.
This is how the Racket web
Good.
Could you repeat that?
I was just saying this is what the source of the Racket.com webpage looks like.
There you go. All right. All right, another one here, keyword parameters. If you look at Objective-C, I just took that because it's a nice syntax. SmallTalk uses essentially the same syntax. It looks a little bit more thing. So the first line, the greeter, greet with first, Joe, we have this, the equivalent in Racket is send a message. And I want to make sure, Allan K said, OO to me means message passing, and then some other things. Like objects are these autonomous little blobs that you send messages to. And that's how you should think about them. The top syntax has one advantage above all else. It's self-documenting. It is literally telling me what each one of the parameters is used for. So we have the SRFI 177, portable keyword arguments. So we have something like this, #:first, and then give the first name, etc. Okay, I guess, maybe. All right, let's look at another language, Ruby. Ruby is an acceptable Lisp, just want to say. All right. So they started out with : something keyword equals bigger than something, comma, move on. The person who created Ruby is called Mats with a Z, and the tagline is Mats is nice, everybody's nice. So some people said, you know, that's a lot of typing for not a lot. And so they said, let's go with number 2. Can we do that? Yeah, they could. So can we? Right? Can we have this? Like so that we use colons as an indicator of a symbol instead? And at the end. And yes, we have, and I know these are just conventions, but they're still there. We are used to this type of syntax. This one, closure, also an acceptable Lisp. So in closure, comma is treated as white space, which basically is true in natural language too. Yeah? So we can have this, and it means that. So if we have that too, we can have something that actually is beginning to look like something people would be familiar with and would be like delighting the user. Okay, so last item. And if you take nothing else with you from this talk, this is the big one. Let's look at indentation. All right, so on the left-hand side here, we have what I would call a modern indentation style. And on the right-hand side, we have the original KNR type indentation style. The one on the right saves vertical space, but it should be viewed with the same overbearing understanding as putting double spaces after periods. belongs in another time. Right? It's from back in the day when monitors were small and things look different. So why is the one on the left superior? Here's the answer. Because it's immediately obvious where things pair. So the cognitive load is lower on the left, as you can tell. But I know somebody's already going to Facebook and going, well, actually. Right? And if you like the one on the right, it's probably because you're an expert programmer who spent a lot of time getting used to that style. Yeah? The other one I hear a lot is like, yeah, but my editor will show me. But it shouldn't have to. It should be immediately obvious where your delineations are. You should not have to use some tool to see that. And it'll save you a lot of anguish if you do that. There are two other languages. So there's Python, also an acceptable Lisp. They were the first to get rid of the semicolon, so they got something right. They essentially don't have an ending curly brace or an ending delineation. The other one's from Ruby, and they kept the ends, and they're sort of indented accordingly, but they're still white space dependent, which I thought was a really horrible idea, but it seems to be really working these new languages. So here's something I completely stole from a paper, an article from somebody who's here. Right. The one on the left is a student, and the one on the right is an experienced programmer or an experienced Lisp programmer. And you can see that they had two different intentions in mind. They were doing two different things here. The one on the left is thinking in, I want to say, curly brace type thinking. And the one on the right, we're just thinking about firing up functions. Loose terms there. The question is, where does the parentheses for 4 go? And if it takes you more than a second, we're doing something wrong. So, let's do this. Right? If we have a parenthesis that finishes up something, let's put it where it's easy to find. Yeah. Hey. So okay, let me explain what I'm doing here, right? So what I'm trying to are you saying there's a bug in my slide?
The close part at the end of the first line, it should be in the next line.
Wait, hold it, right? So we don't have to have a conversation about whether the opening delineator goes at the beginning or the end of the line, right? There's no doubt it has to go in front. It's therefore at the beginning of the line, which makes it easy to match the parentheses. Let me just show you, right? So is it easy to figure out where they open and close, which ones belong to which one? Essentially, if I'm down here, I know exactly which one opening parentheses to look for. Now, I'm an educator. I'm trying to make life easy for my students. So this is where we're at. Okay, so what I'm proposing is new rules of indentation.
You really got us. You're brave.
It's Sunday morning, we'll keep it light. Okay, rule number 1, if the expression is closed on a separate line, then indent the closing parentheses to match the opening parentheses. Not too difficult, right? Rule number 2. All right, so let's look at that, right? Where does the 4 end? Yeah, right? Right.
Somewhere,
Yeah, it's hard to see, I know. Well, come closer. All right, so back to our intrepid defender of our beloved language. Here. So the question is, like, Racket is perfect, somewhat. But if you want to make it perfect for me, here's my wish list. Can we use function instead of Lambda, at least in the beginning student languages, please? Can we use capitalized class names and get with the rest of the crowd? Can we give a name to... Right. Can we have hashtag lang HTML? And just think about this for a second. What if the people who made Ruby on Rails had done Ruby on Racket? We would be all over the world by now. Yeah. And it's even, you don't even have to change the lettering, right? It's ROR, it works. Okay, can we have symbols that end with a colon at the end? Can we have keywords that end with a colon at the end? Can comma become a white space? And the one, if nothing else takes here, can we please put the closing parentheses under the other one, just like you would do in all the prickly languages? And with that, please, Matthew, please. Thank you. No, that's only if they close on a different line.
Oh, so
Yeah.
option.
No, if they close on the same line, you keep them there. But if they close on a different line, that's why there were two rules. Right? Yeah. Any questions? Yeah, I didn't think so.
So there are various things I might quibble with in the talk. But I think the main one is you keep looking at me. That's not how this works. We built a language for making programming languages. Go do it. Build the thing that had all the right pieces in it and use that and pull other people together. Right? Now, I know there are various reasons it's not as simple as that, but the higher order bit there, it's not about me, it's about everybody here and about what languages you can make.
But you're the one with all the undergrads.
You just write a bunch of macros for some of them.
All right, thank you.
Yeah, we'll probably take 5 minutes of questions, even though we're over time, just because it's the break and it's the last talk, and I'm sure there's going to be a lot of opinions.
Oh, I should take this off, right?
Yeah. Well, no, we'll keep it on.
Oh,
yeah.
sure.
Yeah.
Sure.
All right, we have. Well, you shouldn't have picked on JavaScript.
So I have never used Racket. I barely know what it is. I love what you're proposing.
Thank you. And especially coming from you, I really appreciate it. We did not arrange this ahead of time, just so you know.
Hi, Nathaniel from Northwestern. One thing that you said I thought was really interesting, and it was that people would say, oh, my IDE will just tell me what the matching paren is. So I'm wondering, do you see, do you believe that the design of a language should be oriented towards a person reading the program in plain text, black on a white background? Or should it be oriented with the knowledge that people will have tools that can make it more of an interactive process reading a program?
So I don't know that a lot of people read programs on paper anymore, which means color is definitely an option. So you can, you want that. And having the code be interactive is also a great idea. But what I'm sort of saying, I shouldn't have to move my hand to the keyboard or the mouse in order to find out what the structures are. It should be immediately obvious. If I have to do that, I'm missing the point.
I guess, why?
Okay, because it reduces the cognitive load and it's much faster.
Okay.
Thank you.
Thank you.
Good.
All right. Let's give it up again for Allan.